Today, we will talk about artificial intelligence for disaster risk reduction. And for that, we have 4 different speakers from 4 different countries. And they will share about their work related to disaster risk reduction, and especially employing artificial intelligence methods. Before we begin, I'd like to say a few things to our participants in this session. First, because this is a virtual session, please accept our apologies for any technical glitches during the session. Second, this program will last about 1.5 hours from now. And third, please type your questions in the chat box, and our speakers will answer all the questions in Q&A session only. And if you are interested in getting the certificate of participation, please fill the Google form that will be shared in the chat box with your all details, and we will send you the e-certificates within 2 days. Now, without further delay, I would like to introduce our first speaker. Our first speaker for today is Mr. Lorenzo Nava, and he is PhD student at the University of Padua in Italy, and he works with artificial intelligence and remote sensing to detect landslides, and he especially works with synthetic aperture radar SAR datasets. He also develops open source GIS tools for landslide detection and also for forecasting. With this note, I would like to invite Mr. Lorenzo Nava for his presentation. So Mr. Lorenzo, the floor is yours. Thank you.
Hello everybody. Hello Kshitij. Thank you, Inspire and Kshitij, for inviting me here. It's a pleasure. I will share my screen. Please tell me if you see it correctly.
It's perfect.
Okay, perfect. I will talk about deep learning for landslides. The contents of the presentation will be a short overview of artificial intelligence. Then we will talk about convolutional neural networks. And then I brought 3 study cases just that you can use for example to see what you can do with convolutional neural networks. So the first one is landslide mapping. The second one is building detection, and the third one is landslide detection, but on SAR data. We have a huge quantity of data. They can be from satellites, from aerial imagery, it can be from ground-based stations, and also UAV. So we have those data from different parts of the globe, and those data can be processed and they can be different. So from this huge amount of data, we are not able to exploit all those data on our own, but we need help, and this help can be given from the artificial intelligence, for example. Usually we think about artificial intelligence as the robots, but in reality, artificial intelligence is any technique that enables computer to mimic human intelligence. There is a subset of artificial intelligence called machine learning that comprises all statistical techniques that enable machines to improve a task with experience. So you can train those algorithms. And there is another subset of machine learning that is called deep learning, that are multi-layer neural networks that learn from vast amount of data. So in the deep learning, we can find the convolutional neural networks. I will show some applications. So for example, image recognition, face recognition on social media, image analysis in healthcare, and also object detection for self-driving cars. Those are the main examples. And there's a main requirement, and it's to own a huge data set of labeled images. Let's suppose we have trained these CNN with thousands of images of cats and dogs, and now we want this CNN to make prediction on those two images. So if we trained the network correctly, we will see that the prediction are dog for the dog and cat for the cat. So this is a simple example just to understand. Now I will bring the three study cases from my team in Padua. I cannot skip the slide. Okay, yes, I did. So the first one is the landslide mapping. This is from Sansar. And here we are in the southwest of India, is Western Ghats. And here an intense rainfall triggered numerous floods and landslides. So what Sansar did was to train this algorithm that is able to map actually landslides. On the right, you can see small tiles of the study area. And you can see in green the true positives, so the pixels that were predicted correctly as landslides. And then in red and blue, there are some prediction errors, but as you can see, are small errors. And this example I wanted to bring to you because usually convolutional neural networks at the beginning were used to on RGB imagery. So in this case, he used, yes, RGB, but he used also NDVI and topographical factors. Here's the second example. This is a building detection for the evaluation of the element risk. This is from Kushanov. Here we are in Palakkad, so southwest India, and he did a building detection by using convolutional neural networks and just RGB data. And what we can see is that he used very high resolution imagery, but we can see the difference between the only available data before he did the research, that is in black in the right image, so the global urban footprint, and his analysis. Also is important, I brought you this example because you can see that you can create footprints of buildings for really large areas in a few hours, in this case. Before getting to the last example, I wanted to show you what is synthetic aperture radar. Let's just say that you emit a signal and then you collect the echoes. So this is an instrument that can be on satellites, but also on plane and also ground-based. Let's take, for example, Sentinel-1 imagery. So we have a satellite with SAR. We have different advantages. So in the first one is that images are available also in presence of thick cloud cover. And this is a good advantage. Also, they are available during the night. And they are sensitive to geometry and moisture. There are some disadvantages though. One is that images are usually noisy and there are also some geometric distortions. For example, they can be due to the high slopes. And here you can see a SAR image. In this case, in this image, there are some landslides. It's difficult to recognize them just from this image. Maybe this can help. This is an RGB of the same area. And this is to show you that, yes, there are some advantages, but it's not simple to exploit those images on our own. So here, artificial intelligence maybe can help us. And this is the third example. So this is from me. And what we did was to combine different bands of the Sentinel-1 data. This is multi-temporal in this case. And you can see in yellow the ground truth, so where the landslide actually are, and in red the predictions. In this case, we didn't predict, it wasn't a pixel-based detection, but it was an object-based. So we are just showing the area where the landslide should be. Here, I wanted to show you some of the websites where I learned, and that are, for example, TensorFlow contains various tutorials which you can take inspiration from, and also it explains really in a good way, in a simple way, how to use codes and artificial intelligence, deep learning mainly. Here, okay, then there's GitHub, in which people can share their codes, so you're going to find really interesting things. And the last one is Google Colab, that in addition to having different codes from people, you can also code yourself, your codes freely if you don't have a good machines where to. Here you can find the references of the works that I showed you, and really thank you for your attention.
Thank you very much, Mr. Lorenzo Nava, for your really interesting presentation. I think this is very interesting for all our participants, and I personally learned a lot. This SAR data is really powerful because it is not affected by cloud, and especially for in Himalayan regions where monsoon, in monsoon, all the areas are covered by cloud, and our optical images cannot do that. So learning SAR would be really great. Maybe I'd love to invite you for maybe a hands-on session sometime soon, so that we can also learn how to do these things. And thank you very much. And
it will be a pleasure.
Yeah, the idea of chocolate talk is that this is a Saturday time, and so you can enjoy chocolate or coffee. Here is mine, and so you can also enjoy our webinar. And with that note, I'd like to move to now our second speaker. I'd like to introduce her. She is Dr. Madina Mansurova from Kazakhstan, and she is head of the Department of Artificial Intelligence and Big Data in Al-Farabi, Kazakh National University in Kazakhstan. Dr. Madina is a supervisor of the state scientific projects and also the member of national team of higher education reform experts in Kazakhstan. Today, she will talk about AI-based monitoring of mountain glaciers for climate change and disaster risk reduction. So without further delay, I'd like to invite Dr. Madina for her presentation. Dr. Madina, the floor is yours, please.
Okay. Hello, dear participants of Chocolate Talk of Disaster Risk Reduction. So let me present my research results. Just a moment. Okay. And my topic is artificial intelligence based monitoring of mountain glaciers for climate change and disaster management. So let me tell a bit about our university. Al-Farabi Kazakh National University is one of the biggest universities in Central Asia and one of the leaders in the world ranking, entering 175th place in QS ranking system. And me, Madina Mansurova, I work in the Department of Artificial Intelligence and Big Data. So all of us know the glaciers are the sources of fresh water, and the role of the glaciers is very important for us. And we know that the volume of the fresh water is decreasing, and glaciers are continuing to shrink with a high frequency. So it is necessary to prevent a decline in fresh water supplies. Our research concerns this problem, and we understand that necessary to develop effective and efficient methods to map and delineate the boundaries of the glaciers. And these systems, these methods can help us to monitor of dynamics of glacier change and manage freshwater reduction. So, just a moment. Here we can see the aims of our research. First of all, develop of architecture of monitoring of remote monitoring system. Develop of methods for glacier mapping from satellite images. Develop of web-based tool, and then organize the remote monitoring of glaciers. The object of our research is Tuyuksu Glacier. This is a big glacier, and this is source of fresh water for Almaty region. And here you can see the characteristics of this glacier. On average, unfortunately, on average, 10 meters of the Tuyuksu Glacier shrinks per year, and it is a big problem. This figure shows the change in the area of the Tuyuksu Central Glacier for the period from 1958 to 2016. And we see the decrease in the area of this glacier. And according to the pessimistic prediction, this glacier can be deleted if now we don't do anything to prevent this problem. Here we see the architecture of our system and the components of the system. First of all, the first component, data collection, data pre-processing, and data processing. Then the last step or last component of the system, web tool. Let me present the pre-processing stage. We use the Landsat 7 images. Then we create the labels using the Google Earth Engine. We work in this environment on this platform. And to do our research, we perform some necessary steps as calculation, corresponding indexes, as creating vector data. Then we converting this vector data into image masks. Then we use these Tuyuksu characteristics in our system. The next step is the processing step. As a previous speaker, we use the deep learning methods, the convolutional deep neural networks, UNet, and we receive the good results, and we now understand that this method is one of the best methods for semantic segmentation and to do our research. All of this work allows us to create the glacier mapping tool. And this is interactive tool. We can check or validate our methods. We can receive the different types of outcomes, and all of this information help us to do some conclusions, to use this information for decision making. And here we see once the results. This is graph of annual mass balance of the Tuyuksu Glacier according to given data. And this graph shows us the difference between accumulation, snowfall, and ablation, snow melt. And we see that the ablation is superior to accumulation. And we see the problem. And this graph demonstrates this process. Just a moment, next slide. We use the GLIMS database to implement the mapping process because dataset GLIMS allows to work with the contours of glaciers and display information about the current glacier. And this information can be used, the specialists from geoinformation sciences, and can be useful to do some maybe political decisions or decisions by ecological committees. The next result of our research and the output of our system is snow albedo daily layer output. And this function provided to demonstrate the depth of the season, according to the season, the depth of the snow. And the time-lapse creation tool help us or provide us to monitoring the change of a glacier from some period. And here we want to demonstrate the changing in area of glaciers. Yes. And as conclusion, I want to say that this research concerns the big problem, the glacier area reduction, and monitoring help us to see and to validate the parameters of reduction and maybe do something to prevent this, to decrease the speed of this process. The developed web tool help us to see the results, to verify the new algorithms, maybe with a higher quality, and to receive the other parameters concerning the glaciers. And some words about future research. We need to be done to develop new network architectures or change the parameters of network architectures, and indicate the criteria that better use domain knowledge. And these tools and these algorithms can be used not only to the current Tuyuksu glacier, but to other glaciers, and maybe to monitor and investigate the regions outside the glacier. Thank you very much for your attention.
Thank you very much, Dr. Madina, for your really amazing presentation. I personally enjoyed a lot, and I hope our participants also enjoyed a lot. And thank you very much for accepting our invitation from Kazakh National University. It's also good to know about the university, the leading university in Central Asia. And especially love the part that you are using Google Earth Engine. So that might be interesting for our young people to learn and explore more about. So thank you very much, Dr. Madina. Now I would like to move to the third presentation, and our third speaker is Ms. Badal Pokharel. She is a PhD student at the University of New South Wales in Australia, and she works on recognizing, analyzing, and assessing earthquake-triggered landslides in the Himalayas using machine learning and remote sensing techniques. Today, she will talk about machine learning algorithms applied for landslide susceptibility. So without further delay, I'd like to invite our third speaker, Ms. Badal, for her presentation. Ms. Badal, please, the floor is yours.
Just trying to share my screen. I was trying to fill up. How do I get rid of this? All right. Is it fine?
Yes, perfect.
Hang on. All right. Thank you so much for the invitation. I think Lorenzo already covered most few parts of landslides. So today I'll be talking about machine learning in landslide susceptibility. I'm going to skip this part, but just I just put some stuck on some slides regarding what is landslide and stuff. So in general, like landslide, as we can see in the screen, it's a kind of natural hazard disaster, a movement of rock or debris floor or down the slope. The most common landslide that we talk about are landslides, which are slides, rock slide or soil slide, slump, rock fall, debris flow, and so on. So before diving in the content that I've been working with, I would like to just talk something about landslide susceptibility and hazard, because I think these are two dynamics that sometimes we are confused about. So in general, landslide susceptibility is the likelihood of the occurrence of landslide in a particular spatial point, given a specific landslide causative factors. When we put this susceptibility together with the time dimension, or in general frequency, as well as the magnitude of the disaster itself, we come to the hazard. So hazard is combination of these three terminologies. While we are talking about landslide susceptibility mapping or modeling, what we are talking is that generally, which is computer-based work, we are talking about a model that is prepared on the basis of statistical or expert-based or machine learning algorithm implementation within that model. And what we get is landslide susceptibility map. So I think we are mostly this talk is about disaster risk reduction. So I'm trying to connect the technical aspect of landslide susceptibility into the DRR. In terms of landslide, I think landslide risk management or reduction is kind of the proper word that connects with disaster risk reduction. And when we put susceptibility, hazard, and risk zoning, we get landslide risk management. In the trendy way or trendy practices that are used by different researchers for landslide susceptibility are physical-based model or expert-based models, statistical model, and machine learning models recently. And there's a very thin line that actually differentiates the statistical model and machine learning models, which is kind of confusing a lot of times. So what happens in statistical model is we are using certain statistic to represent the data in the best way. In case of machine learning, we are using mathematical or statistical approaches to give the best prediction of something. So there is no implementation of rule-based function, rather use of the statistical or mathematical approaches to develop predictive models. If we see in the past and present, we can see that statistics and machine learning things are not overlapping. They're totally different things as understood by researchers. But recently, this is in overlaps. So for instance, logistic regression, right? So logistic regression is statistic, but we use logistic regression as a machine learning approach to generate a predictive model. So this is how we are defining machine learning or using machine learning trends in these days. A short glance of how these methods are trending these days is that we can see machine learning have been it's a good graph that shows the exponential growth of how machine learning algorithms has been, applied for several researches and so on. So this is just a glance that I wanted to show. Some case studies in which I have put one of my works and also a few examples from the other part of the world that researchers have done in case of machine learning and landslide susceptibility. So this is one of my work in the central part of the Nepal Himalayas here. And the work that I have done here is studying the spatial clustering and modeling of the studying the clustering nature of the landslide, and then using those clustering algorithms in generating landslide susceptibility maps. So these are few pictures of landslide from this study area. So what we have done is that we had 639 landslide locations, which were mapped manually. After listening to Lorenzo's presentation, maybe the future work would be some kind of semi-automated or automated feature recognition in landslide, and then using machine learning for the next part. So for the 639 landslide, first we clustered, we run unsupervised clustering algorithms like Gaussian method, GMM, which is Gaussian mixer modeling, hierarchical clustering analysis, k-medioid, k-means, and so on. Also, we prepare a random pattern. Like what we generally do in landslide susceptibility is we have 639 landslide, right? So we just divide them into 70-30 and then run the algorithm. But what we did here is we prepare 6 clustering data set and 1 random data set, and then we divided them into 70-30 for each of these unsupervised clustering algorithm and a random sampling. After that, we input some landslide causative factors, which were more like the geomorphometric factors, for example, slope, aspect, and so on. And then we put them into logistic regression model. And then we also studied different comparisons on how these data are significant or how these data differ from each other. So we also performed several statistical tests, and then we finally plotted receiver's operating curve and chose the best pattern to develop landslide susceptibility map. So we can see in the graph that for each of these unsupervised clustering algorithm data set and 1 random data set, we also studied about the significance of the landslide causative factors in each of these clustering method. So it shows that, for example, if I take let's take the red one, which is slope aspect. So we can see that for one cluster, the aspect has certain value of significance, but for another cluster, like say this one or this one, it has high. So this also shows that how our susceptibility maps are actually influenced by the way we sample our data, right? So this was one of the study. And also we check the modeling accuracy for each clustering data set and random data set, which shows that Gaussian mixer model had the highest accuracy, followed by k-means and so on. So the random sampling that we did, 70-30, it was actually, this was the 4 other unsupervised clustering data set actually outperformed the accuracy of random data sets. So this shows that actually the machine learning approaches will actually help us to improvise the model. Also, for the receiver operating curve, we received 95% of the rate for the GMM, and finally we generated landslide based on this unsupervised clustering data set. So that was my study. Just the main conclusion of this study is that we can use machine learning approaches or unsupervised clustering approaches to improvise our landslide susceptibility maps or to get more effective predictive models, right? There are 2 examples that I put on here just to share with you that how we are moving forward with machine learning and landslide susceptibility. So this was a study which was done in Southeast Asia. And then there are certain methods used, which are few of which are actually new to me. For example, gradient boosting, distance tree, these are few things that I have not used. So I'm not getting into the numbers, but what I want to show is that we are actually using machine learning like random forest these days a lot. And getting something out of that, getting a certain good results out of that. This is one of the best paper I've read these days, because while we are talking about disaster risk reduction, what we want to do is we want to connect our technical part with the community level, and then we can show people that, okay, this is how science and society interface works and how we can actually help for the disaster risk reduction. So there's a quote to quote lines from the paper that it says the application of study in refugee management and reside in refugee management and landslide susceptibility mapping of Rohingya camps, which can potentially save refugees' life and serve as a case study for global application. So this is how, one of the good example how the technical aspect like artificial intelligence actually can connect to the community level. So my take home message would be that, of course, machine learning algorithms, as we saw in the first 2 presentation by Dr. Madina and then Lorenzo, that these are potentially a valuable tool to develop good landslide hazard mapping and ultimately contribute in landslide risk reduction. But one of the most challenging part is that while we are using this machine learning techniques. For example, say I might get a good number for logistic regression, a less good number for random forest for ABC area. But while I use those methods in next study area, that might be vice versa. So this is one of the challenges, because the performance not only depends on the the model we use, but there are certain uncertainties that are related to it. And next thing is that for the regional studies or for preliminary assessment, these are the best thing. But when we go deeper, I think physical model outperforms the machine learning to some extent in disaster risk reduction. So that would be two challenging stuff. So by saying this, I just conclude my presentation. Thank you.
Thank you very much, Ms. Badal, for amazing presentation. It's really amazing to know that actually machine learning can help us to know probable future locations of landslides. So if we know, when you know where landslides can happen, we can of course reduce the risk. And also presented by this Ms. Badal, that there are some challenges. So where there are challenges, we can say that there are opportunities. So especially for young and youth professionals, I believe there is a huge opportunity to work on this sector, on predicting probable locations of future like landslides, or it can be floods or forest fires. So I think this would be really interesting presentation for all of us. So with this, I'd like to move to our fourth speaker for today. And our fourth speaker is Dr. Halda Aditya from Indonesia. Dr. Aditya is a coordinator for the application of technology section at the National Laboratory of Weather Modification in Indonesia. And Dr. Aditya is also an awardee of Presidential Medal for conducting cloud seeding operation for disaster risk mitigation. I personally really interested to know how this cloud seeding operation works. So I hope our speaker will present about that. And today he will talk about mitigating forest fire with artificial intelligence. So without further delay, I would like to welcome our fourth speaker, Dr. Aditya from Indonesia. Dr. Aditya, the floor is yours.
Thank you very much, Kshitij, for the opportunity. So first, maybe I try to share my screen. Okay, without further ado, maybe I will start my presentation. Hello, everyone.
Perfect.
My name is Halda Aditya. You can call me Adit. Today, I will present one of our team work during the last 2 years about the forest fire prevention, or how we mitigate forest fire using weather modifications technology based on artificial intelligence. My office is the National Laboratory for Weather Modification Technology. So this is my content. I will talk about background. Like Kshitij says, I will mention a little about the weather modification itself, and then I will talk about the forest fire and the other stakeholder. Also, I will talk about data, methodology, and the model we built on these applications. So first of all, the definition of weather modification technologies, we are intervention on cloud development process for enhancing or suppressing rainfall intensity. So we basically work on clouds. We make the rain, we make the cloud grow faster and make more rain to the surface. In Indonesia, weather modification technology is used for the rain enhancements, rain suppressions, and also fire suppression based due to the forest fires. This is the general view of our service area. We are working around Indonesia for the agriculture, hydropower plant dam, forest fires, and also rewetting peatland. And we are using this technology for the mining operations and other events. So we also have the president directive about the forest fire mitigations. My president told us to use of technology for monitoring and supervisions, and in detail he gave the instruction earlier last year, the role for BPPT in combating forest and land fire by using weather modification technology for peatland wetting or re-wetting the peatland. This is the hotspot occurrence over Indonesia. We are collecting from 2016 until 2020. The hotspot occurrence usually happens in the dry season in Indonesia. Meanwhile, our office responds user in mitigating land and forest fire every year. However, the timelines of the implementation become problem. Why? Because we work on the clouds. In the dry seasons, there are low relative humidity, low convective activity. It's causing the clouds cannot grow high and we cannot work in these dry seasons. So it's difficult to finding potential cloud in dry season because the cloud seeding operation to be less effective. We are usually work in the transition season during the wet to the dry season or dry to the wet seasons. So this is data about losses from the forest and land fire in Indonesia. So there are many land fires. For example, in 2015, more than 2 million hectare hours are burned. And also the silver one, 2018 and 2019, more than 1 million hectare hours are burned. And the total loss is estimated around 5.2 billions. So this forest fire in Indonesia are 90% anthropogenic disaster. Why? Because the people are clearing the land by slash and burns. So our technology was hoping to mitigate those action by we make the peatland very wet or maybe flooded even if it's possible. So the people cannot burn the land easily because in the peatland, it's already on fires. The core of the fire can be underground for 1 meter or 2 meter below the ground. So it's very difficult to make the fires shut down. So we hope we can use the cloud seeding operations before the fires are happening, and in order to make the peatland more wet so it cannot easily burn. And how we do that? We have a vision that the cross-functional forest fire fighting force, our office and the National Meteorological Agency, the Disaster Agency, and the the firefighters in the field can make optimized decision to prevent forest fire based on the evidence-based predictions of the forest situations. This evidence-based recommendation in advance help us to mitigate what steps do we need to act next to prevent the forest fires. So before we are talking about the machine learning, the AI, we need to know the data first. What do we have? In Indonesia, there are many tools available for monitoring the forest fires, but all this application, all this monitoring did not the capability to forecast. We cannot know when will the peatland become very dry and easily burn. So based on this exploration of the data, then we decided to predict the peatland groundwater level based on the observation data. Okay, this application used the water level sensors owned by the Peatland and Mangrove Association Agency or BRGM in Indonesia. It's located in the 6th province of Indonesia in Riau, Sumatera Selatan, Jambi, Kalimantan Barat, Kalimantan Tengah, and Kalimantan Selatan. We have more than 150 stations data, but nowadays the active station is around 90 stations that send data to the servers. And among the 90, only 75 stations who have more than 80% completeness of the data. The data availability itself, it's from 2018 to 2021. We use the temporal resolution of the daily temporal resolution, but the sensor itself send the data every 10 minutes to the servers. Okay, now we are entering the methodology. The first thing first is we are certainly must do the data pre-processing, and then we do the seasonality analysis, and then we test the models and evaluate the models that we want to use for predictions. In the data pre-processing, we are collecting data, record the data, and collect all required data need for the analysis. All this data, then we explore it. How we explore, we understand the data in detail using statistics, chart plots, and visualization as tools to look the data attributes and find correlations. After that, we do the data wrangling. Here, we are managing the missing values from the sensors. We are managing the data inconsistency. We are correcting the data into our formats. And then the data is ready for model. This is the example of how we exploited the data analysis. We make auto correlation functions for the groundwater levels. And we also the cross correlation functions between water level, soil moisture, and soil temperatures. And then we also make the data more model ready. For example, we interpolate the data in the missing data, and then we repair the format so that our script can read it easily. And for the data we use, we are handling more over than 2 million lines of data. By using manually, maybe it's a very big job, but if we are using the AI methodology, yeah, I think it's very helping us to do the data pre-processing. After data pre-processing, then we do the seasonality analysis. This analysis is useful for us to see if the data have some trend of seasonal in it, whether it be weekly trend or the monthly trends. At the first, we cannot do the yearly trend analysis due to the limitation of available data, because when we receive the original data, it's only have 2.5 years, so we cannot see the trend in the yearly time scales. So after we have the data ready, then we do the modeling process. Here we have two methodology. First, the ETS models, which is a method in time series forecasting that use one variable or univariate and focus on trends and seasonality. So we are using the water levels data to forecast the water level data itself in several months in advance. And also, this is some our new work. We are using random forests, which is the machine learning methods that are built from many decision tree and can be used in case of regressions and classifications. First, the ETS models, which is the exponential smoothing method, which have three main parameters: error, trends, and the seasonality, which can be additive, multiplicative, or none of the above. And the ETS await the past data in exponential manner. So the most recent data has the greater weight. So in this our example, if we want to forecast the next 3 months, we need to use 3-month data observation for the training. So for the same one, if we want to forecast next 1 year of the water level, so we need to train data 1 year previously. And this is the mean average percentage error of all the station that we model. So in general, the map is below 2%, but yeah, due to the hydrological conditions, I think not all stations show very good map percentage error, but the ETS model give the smallest number of errors compared to other algorithm or other models like ANOVA or moving average. This is from Riau province. The highest level of map is in Teluk Piau, around 3%, and then in Jambi and Sumatera Selatan, same. Kalimantan Tengah, Kalimantan Barat, and Kalimantan Selatan. So the spreadness of the sensors also show not very good map error. For example, in Kalimantan Selatan, we have only 3 stations data, and the stations show relatively higher map error compared to other provinces. This is the recent work done by our team. We are using the random forest is a development of the decision tree method can be used in both regression and classification cases. So we use the regressions. In this case, we use the regressions. Although many papers show the random forest is a robust model, but it cannot extrapolate a trend like the ETS model do. So the range predictions generated depend on the highest and lowest value in the training data. So it depends on how the predictors. So we do analyze using the numbers. First of all, we include all the variable like soil moisture, soil temperatures, rainfall, year, day, month, and also to predict the water levels. From that, we evaluate the map value and then the variable importance. And then we continue to the final model, which only significant model by seeing the value in ink node purity. This is the parameter that describe how important the variable in the decision tree models. So this is the result. Each location has different model performance. I think it is due to the hydrological condition of each nearby station's hydrology. So there are very good mapping error like in Sumberjaya and Merbau, but we cannot see the same result in the Muntai, even though in the station is located in the same province. So we also relatively good result in this station Anjungan Dalam Kalbar, but very bad decision in Bram Itam in Jambi province. And also due to the target variables involved in each final model are different. So maybe in these stations, we are using three parameters like rainfall, soil moistures, and soil temperature to forecast the water level. But maybe in Anjungan Kalam, Kalbar, we are only using the soil moistures due to the evaluation of the random forest models. So this is the applications. The peatland hydrological data use is always up to date, and groundwater level predictions updated regularly every 2 weeks. This groundwater level prediction is used as a reference in making decisions. This is the important part. We use this result to make the decisions when the applications of weather modification technology for disaster mitigation and forest land fires. And also by this time series forecasting, our office can make early decision to inform related stakeholder like the Ministry of Environment and Forestry and also disaster agency to make ready themselves in order to prevent the people who want to burn the forest fire, because we see there are some trend of the water level is decreasing in several months ahead. So this is also a warning from the people around the peatland that your land is very dry. Do not burn your land, otherwise it can be a disaster happens. I think that's all my talk. Teach. Thank you very much.
Thank you very much, Dr. Aditya. It's really amazing presentation. I really like it. And we also, this is, I think, also very timely, because in Nepal this year, we had to close our schools and other offices, not because of COVID pandemic, but because of forest fire and air pollution. So this research is very timely, and I hope this could significantly benefit other countries as well. And I really like that you train model from previous years and test for next year. Also try to predict on a time series basis with seasonal and monthly trends. So thank you very much for joining us today. And yeah, I'd like to thank all the speakers, and I would also like to inform our participants that our presentation session is over. Now we move to the question and answer session, and I'd like to request all our speakers to be ready to answer our questions. So I'll pick the questions and for our speakers, and you can unmute yourself and answer the questions. So here we go. The first question is for Mr. Lorenzo from Mr. Kshitij. He is asking, I would like to ask about the data set. How can we get this training data set, or how can you prepare this training data set? So Mr. Lorenzo, could you please answer this?
Thank you for the question, Tech. And this database, we created it by sampling those images. The third example, right?
Yeah.
Okay, so we sampled from ArcGIS by using the tool that is called Export Training Data for Deep Learning. With this tool, you design some polygons on your targets, and then you sample. It's better also that you supervise the data set after you sample it, because sometimes the tool is can be bugged, and it's better to supervise all the data set for the landslide class, but also for the non-landslide class.
Thank you, Lorenzo. Maybe he is asking if these kind of data sets are available freely, or do we have to create this manually?
We never talked with the team about sharing the data set, but maybe we will share the code after publication, or we are going to exploit the code for producing some framework or application that people can use. We are discussing it.
Okay, perfect. Thank you, Lorenzo. Next question is from Mr. Kausal Gyamali, and this question is for Dr. Madina. So the question is how the model handles difference in snow movement versus the underneath ice movement in glaciers.
Okay, thank you for the question. And I want to say that Landsat satellites have the special satellites operating tools, have the special tool instrument to work with the snow cover depths. And in this case, to verify or to estimate the depth of the snow cover, you can use the tool with the infrared waves. And to estimate the depth of the glacier, you can use the GLIMS data set and the corresponding tools, because in GLIMS data set tools, the system uses deep learning algorithms which can detect the snow material and snow glacier with higher accuracy.
Thank you, Dr. Madina. I think that answers. And now I want to move to next question. This question is for Ms. Badal Pokharel. Actually, there are two questions, so I think these are quite related. So I'd like to ask these both questions. The first question is from Susmita Aryal. What do you think that controls the number of landslides and area of landslides in Nepal? That's the first question. And second question is from Mr. Kausal Gyamali. And he says, it's interesting to see that sampling strategy matters in landslide susceptibility modeling. The nature of landslide distributions by triggers are different. For example, earthquake trigger, your case, and rainfall trigger, anthropogenic, storm-induced, etc. Do you think your comparison results would still be stable in other triggered conditions? So these are the two questions. I'd like to kindly request Badal to answer this. Thank you.
Thank you. First, thank you so much for the question, guys. I'd like to start from Susmita's question. What are the factors that controls the frequency of landslide in the area, especially in Nepal? So the first thing is that Nepal is the country where we frequently get rainfalls like monsoon season, during monsoon season. So rainfall is obviously one of the most important triggering factors. Apart from that, Nepal is a seismically very active zone. So earthquake is the next triggering factor, but these two are the events that actually contributes to landslides or the number of landslides. In addition to that, we should not forget that Nepal has very interesting geology. most of the landslide that we witness are generally in meta-sedimentary formations. For example, since you are familiar with, since you are in Nepal, so I think you could relate more to this, say Sindhu Palchok or Dading or this kind of hilly, in geographical like terms, hilly regions, where we have transition in the geology with sedimentary and metamorphic rock, or with low or high grade weathering. So the next factor could be geology, also some morphometric factors like slope, and of course there are some anthropogenic factors. So these are the things that contribute to number of landslide or the area of landslides. So I think that answers the question for Susmita. If you are more interested, you can email me anytime. Regarding Kaushal, thank you so much for your question. Landslide itself is a phenomena that has that gives you the clustering sense. For an example, like in case of Gorkha earthquake, the epicenter was in Bahar Park, Gorkha. During many analyses or many researches, you can see that most of these landslides that were triggered by earthquake were clustered around the proximity of the epicenter or the proximity of thrust. So this means that landslide is always intending to occur in the area that has certain relation with something else, some event. So in case of rainfall is an event in itself. For example, if there is rainfall in A station, like very high intense rainfall, and in B station there is less rainfall, so the most of the landslide is likely to be clustered in the station A, right? So the main approach of using machine learning algorithms, especially on supervised clustering method, is to study the spatial clustering pattern of a phenomena, which is landslide in our case. So I believe this would fit for rainfall trigger landslide as well, but there have not been any study. So I think we should look forward to put some rainfall parameters and anthropogenic parameters and, do something out there. Thank you.
Thank you, Ms. Badal. So I think that answers. And now I'd like to move to the next question. This question is from Dr. Rahama Hanifa. And this question is actually for all, but now I'm directing this question to Dr. Aditya. I think he would be suitable for this. The question is, I wonder if how AI is currently used for other geological hazards, because we mainly talk about landslide, forest fire, and glacier. So she wants to know about earthquake, tsunami, volcano. And other question is, what is the minimum computer requirement and skill requirement for doing these AI things? Dr. Aditya, could you please answer this? Thank you. Dr. Aditya, you are muted.
Yeah, sorry. Yeah, thank you for the questions, Mbak Rahma. So in our office, PPT, I'm sorry, we not only develop the AI for the forest fires, but we also develop particularly AI for the tsunami. Now we know that we cannot predict earthquake, but after earthquake happens, we can know whether it can be tsunami or not. We in our office, we try to shorten the prediction time of tsunami happenings based on the historical data of earthquake. But I'm not the expert on this. This is another units, but I know we are developing the same artificial intelligence method. How big the tsunami will come after certain time if the earthquake will happen in one place. Yeah, and for others, yeah, maybe if based on my experience using the algorithm of the machine learning and deep learning, I think the key success is the data itself. Like I think Kausal mentioned also in the question. I'm sorry if I take the turn. How about the area that did not have very good data? So we are also developing the hotspot forecasting using the satellite image, of course. So we are using the MODI satellites based on the and we calculate the vegetation area and we calculate a burn ratio, and from that we are using deep learning, the INN method, to forecast all the Indonesia area. not only the location that have the data. But yeah, it can do because we have the data. I think, yeah, it's from my opinion as a hydrometeorological background. But yeah, for volcano, I think no one use the AI for right now. But for tsunami, I can share the BBPT. It's developing the AI for tsunami detections based on the earthquake. I think that answers it.
Thank you, Dr. Aditya. Yeah, it answers well. And thank you. And it's good to know that AI can be useful for other hydrometeorological hazards as well. The other question is that what do you think would be the minimum criteria for computer skill and the data set? Would you please answer this?
Yeah. For the computer skills, maybe we need to know some programming, whether you use Pythons or R language. But nowadays, like Lorenzo said, there's a many resource in the GitHub using the platform of the AI methodology. So our staff only using some laptop with high specification, but not supercomputer to run the models. Yeah, of course we need a supercomputer if the data we use is very big and we need to analyze very much data. Also, we have the supercomputer in BPT. So, but it depends on the data training that we have. We can use the laptops or we can use the supercomputer. And also for the programming skill, yeah, I think the Python and R language is mainly common use for the machine learning and deep learning.
Thank you, Dr. Aditya. And yes, I also personally use my own personal computer and it works with fine data set. But also as shared by Lorenzo and also Dr. Madina, there are some tools that can be used, like Google Earth Engine is free to use, as shown by Dr. Madina, and it also allows artificial intelligence techniques. So maybe we can try that without needing to worry about our computer issues. And also the Google also has a platform for testing these data sets. So thank you, Dr. Aditya. Now I move to next question. I'm not sure to whom to ask, but I'd like to pass this question to Ms. Badal. Since you predict the probable future locations of landslides, how about developing a route analysis for immediate evacuation after disaster? So how can this be done with artificial intelligence? This question is from Mr. Rajesh Dulal.
Thank you so much. I think this is quite related to my research and Lorenzo's as well, because I think Lorenzo showed how convolution CNN could be used for building detection, which is element at risk, right? So I think the main process in doing this would be first locating the element at risk and then finding out the routes, which is like feature extraction. Especially, I think this is this has been, I think, being done in few countries. I would say, I think in Japan, but in case of Nepal, which is very complicated with topography, I think we are more like we should be more like looking at the spaces as well as the routes. In case of Kathmandu, which is very populated area, I think the main thing we should do there is feature extraction and then kind of disaster preparedness of if this intensity hits, this would be the consequence. I mean, this is what we have to do to avoid the bad consequence from the disaster and stuff. Honestly, I don't have experience in early warning system until now, but it would be interesting to do that. I think Lorenzo would be happy to answer this as well, not sure, because that's I think feature
Perfect.
Yeah.
Yeah, I have no experience in like evacuation plans or but yeah, as Badal said, if you detect you can extract footprints from building and from streets, certainly you can do something. One problem is maybe also the time component of the occurrence of the event itself. So maybe we should solve also the time component issue and and then we can do really, really good things to improve the safety. Yeah.
Sorry, I just want to add one thing more, since this
Sure.
clicked while you were talking about the time domain. For example, the earthquake in Nepal happened on Saturday, which means the traffic flow on Saturday was comparatively lower than the weekdays, because Saturday is national holiday. It's a weekly holiday in Nepal, right? So if that event had occurred on Monday, maybe our approach should have been different. Since it occurred during the weekend or the holiday, the few things like traffic controls, the movement of people around the street. So these are some dynamic aspects I think machine learning could work on. We can work on it. Example, like for the roads, we can see what's the flow of the vehicles, kind of, computer aided visioning kind of thing, the virtual reality and stuff. So
this is interesting.
Thank you, Mr. Lorenzo and Badal. Now I move to the next question. This is for Dr. Madina. So there are actually two questions which are quite related. So I'd like to pass both of them. So these are, one is from Mr. Manish Rajgauli, and his question is, can we estimate the inflow rate of water released by snowmelts? And the next question is from Talshan, sorry for pronunciation. And his question is, can this tool be used for other glaciers, like change location and depths, and if that tool can work on that? Dr. Madina.
Yes, okay, thank you for the questions. And the answer to first question, yes, we can estimate, we can calculate the water flow. For this, we can use as I presented in my material, in my research, accumulation and ablation coefficients. And we can use the difference between these values of these parameters, and we can calculate, because the equipment of satellites allow us to do this calculation and estimation. So this is answer for first question. And about the possibility to use these tools, these methods for other glaciers, yes, of course, because we should indicate the place, the glacier, and then we should work with the some marks concerned this glacier, then we can continue the work and use all of these tools to current to interested for us glacier. Okay, thank you.
Thank you, perfect. Thank you, Dr. Madina. So we are running out of the time. So I'd like to take one last question for today, and other questions which could not answer today will be posted in our website, uinspirealliance.org. So please check that. We'll write a blog there, and you can, and we will arrange these questions to be answered positively. So the last question is from Mr. Kausalraj Gyamali to Lorenzo. How big landslides can we detect from SAR? Or maybe how big or small, how would be the size affect the detection in SAR images?
Thank you for the question. I think it is it depends more on the resolution of the data we are using. For example, if you are using Sentinel-1 data, the resolution is 5/20 meters. So let's suppose I think the landslide should be quite big, because we should have more than 1 or 2 or 3 pixels of landslide into the image for being recognizable from the algorithm. But this is, if we are using instead, for example, Capella imagery, so I think they have a resolution of 50 centimeters, if I'm not wrong. Well, with this technology, we can detect also really small landslides. So I think this is the relation is with the data mainly that we are using.
Perfect. Thank you very much, Lorenzo. Now, I'd like to end this question and answer session. And thank you for all participants and for questions. All are good questions. And thank you for our speakers for answering all the questions. Now we move to the key takeaways session. And before that, I'd like to remind our participants that if you are interested in getting the certificate, there is a form in our chat box. Please fill the information correctly and you will get the e-certificate from UNSPIRE Alliance within 2 days. And now for the key takeaways, I'd like to invite Saran Prakash from UNSPIRE Alliance to provide key takeaways for our young and youth professionals who want to work in this sector. Thank you.
Thank you, Kshitij, for that extraordinary session with such well-read experts. I would like to take a couple of minutes to briefly summarize the session with key takeaways from our speakers. Beginning with our first speaker, Mr. Lorenzo. With the growing number of events of windstorms, landslides, earthquakes, and so on in your presentation, you acknowledged the need to be able to intervene quickly to accurately map the impacted areas. You explained the application of convolutional neutral networks, that is CNN application, while also clearly mentioning what all its functioning requires, including a huge data set with labeled images. Then moving on, glaciers are an essential part of our living environment. They are considered to be significant natural regions that need to be preserved and monitored, for they are important sources of fresh water, especially in the arid regions. Dr. Madina shared with us how remote sensing images acquired from different platforms using sensors that operate in different spectral regions have been widely used to study glaciers, for example, the changes in surface elevation over time. Then we moved on to Ms. Badal, presenting on her work in spatial clustering and modeling for landslide susceptibility mapping in the north of Kathmandu Valley, Nepal, highlighting that machine learning algorithms can be used for improving landslide susceptibility models. She noted that they are potentially a valuable tool which can contribute to landslide hazard mapping and ultimately landslide risk reduction. And moving on to a final speaker, Dr. Aditya. Dr. Aditya, you shed light on how your team at BPPT has put efforts for the prevention and reduction of forest and land fires in Indonesia. The most effective method, I understand, was the optimization of weather modification that increases rainfall. You also helped us understand your work with the example of South Sumatra in the peak of dry season. So thank you all the speakers. This was a truly magnetic and unconventional session. Over to you, Kshitij. Thank you once again.
Thank you very much, Saran, for summarizing all the discussions very precisely. And here we come to the almost the end of the session. So before we end, I would like to hand over this session to Dr. Rahma Hanifa, Secretary General of UNSPIRE Alliance, for a thanks note and also announce the next UNSPIRE Alliance webinar. Dr. Rahma, over to you. Thank you, everyone.
Thank you very much, Moderator Kshitij, and I really thank you all the speakers, Lorenzo, Dr. Madina, Ms. Badal, and Dr. Halda Aditya from 4 countries, spanning from Italy, Central Asia, Australia, and Indonesia. From the morning to almost evening in Australia. And also we have participants from many countries, about more than 50 participants, almost 70 participants in YouTube and in Zoom platform. We thank you also for the organizers. The organizers is also not from 1 country, but we are from 5 countries to organize this event. So I really appreciate this international collaboration of youth and young professionals. And I learned a lot also for today's session, because I'm also new to AI and machine learning. I love the way that Lorenzo also provide the diagram of AI and machine learning. I really think like I need some more lecture on AI and machine learning and so on, but it's very happy to see how it is applied to landslide, to glacier monitoring, to forest fire, and also some mention about how it also used for tsunami and earthquakes. And I believe that all of this enabling artificial intelligence can also be in the wider application for disaster risk reduction as well. So I really thank you again. We will also prepare a key takeaway from this webinar, and we hope to also put some blog that we will publish in our website of UInspire Alliance. Our next webinar will be on 25th September. So the Choco DRR talk is every Saturday, fourth Saturday of every month. Next month will be 25th of September. The topic will be risk-informed decision making. And it also includes how AI is used as a base of risk-informed for the decision making. So we also want to see how AI is used closely to the decision makers as well, translating from how we understand hazard, translating to risk information, and translating to how it is used for decision making. So we hope that you can continue joining our Choco DRR talk while enjoying your chocolate as well. And also, if you are interested to join UInspire network, you can contact the UInspire national chapters in our social media. And again, we thank you very much, and we hope that we can keep in touch for the future. And if you don't mind, maybe we or the participants can also email the speakers for further questions or inquiries. So again, thank you very much for all speakers, participants, and organizers. With this, I will close this Choco DRR Talk 3 of today. We apologize for any inconvenience that happens from this meeting. Thank you. So let's take group photo for you who are still here. Please turn on the camera. Okay, yeah, please turn on camera. Okay, let's take 1, 2, 3. One more. 1, 2, 3. Thank you. Thank you again, everyone.
Thank you. Bye.
Thank you.
Thank you. Bye.
U-Inspire Alliance is a network of youth and young professionals working in science, engineering, technology, and innovation.
U-Inspire Alliance provides the platform for youth and young professionals to connect, engage, and learn from other youth and experts in the region.
We are not only at the international conferences or at the laboratories. U-Inspire is working together with the local community in the field.
To participate in decision making, demonstrating their ability for advocacy, communication and consultation, as well as leveraging advanced technology.
We strongly believe that inclusivity is the integral factor of the DRR. Hence, all our work and projects are people-centric and from the communities on the ground.
We are committed to supporting youth leadership. We are happy to work with the U-Inspire Alliance.
U-Inspire Alliance bridges the gap between professionals and young specialists and make it possible to exchange knowledge and experience between Asian countries to make them more resilient.
We work with youth and the young professionals from the academe and the industry sectors to build back better in a post-pandemic world.
U-Inspire has connected us and bring us together to contribute for disaster risk reduction and climate change by utilizing science, engineering, technology, and innovation. Congratulations, everyone. Why there are still people in the waiting room?
Congratulations, everyone.